Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using the concepts of derivatives. So as per the problem, a particle moves along a straight line with the equation of motion s equals 1 over 3t cube minus 2t square plus 3t, and t is greater than or equal to 0. So t represents the time. Now in part A, we have to find the particle's velocity and acceleration at any time t. So we know that the velocity function is the derivative of the position function. So the first step here is to find the derivative of this position function. So we know that v at t, so the velocity function is equal to the derivative of the given position function, so prime of s, and now we have to find the derivative of the three terms in this position function. So for the first term, we'll use the power rule. So the coefficient 1 over 3 will stay as it is, times. So as per the power rule, we'll move the 3 to the front, so we get 3, and then subtract 1 from the exponent. And then minus. So in the second term, we'll use the power rule again. So 2 is the coefficient, and then times 2, and then times t exponent 2 minus 1. And now we can also use the power rule for the last term, 3t, and the derivative will be just 3. So now we can simplify this expression. So v at t equals, so 1 over 3 times 3 is just 1. So we get t squared, and then minus 4t, because 2 minus 1 is 1. We do not write 1 as a exponent, and then plus 3. So this is the velocity at any time t. Now we can find the acceleration function, and the acceleration function is the derivative of the velocity function. So prime of v at t. Now we have to find the derivative of these three terms. So the derivative of t square is 2t. As per the power rule, the derivative of minus 4t is just minus 4. And the derivative of 3 is 0 because 3 is a constant. So the acceleration function is a equals 2t minus 4. So this should be the final answer for part A. So now we can analyze part B. So in part B, we have to find when does the motion of the particle change direction. Now motion of a particle changes direction when the velocity changes from negative to positive or positive to negative. So there's a very important concept you need to understand and memorize. Now in order for velocity to change direction from positive to negative or negative to positive, the velocity has to become 0, and then the sign of the velocity will change. So the first step here is to find the times at which the velocity becomes equal to 0. So for that, we'll use the velocity function, and the velocity function we found is v at t equals t squared minus 4t plus 3. So we have to set this function equal to 0 and then solve for t. Now this equation is a simple trinomial, so we can use factoring to solve this equation. So we can use the sum and the product rule. So we have to find two numbers, sum equal to negative 4 and the product is equal to 3. And the numbers are negative 3 and negative 1. So the factored form of this equation will be, so 0 equals, so t minus 3 times t minus 1. And from this we get two cases. So the first case is t minus 3 equals 0, and the second case is t minus 1 equals 0. So the first solution is t equals 3 and the other one equals 1. So these are the two times at which the particle changes direction. Now we can also visualize it because the velocity function is a quadratic function. The graph represents the parabola and these two t values represent the x-intercepts of the parabola. So at these x-intercepts, the parabola will go through the x-axis. So therefore the sign of the velocity will change at these two t values. So therefore the motion of the particle changes direction at these two times. So now we can analyze part C. So in part C we have to find when does the particle return to its initial position. So the first step here is to find the initial position of the particle because we are not given the starting point of the particle. So for that we'll sub in t as 0 in this position function. So s at 0 is equal to 1 over 3 times 0 cube minus 2 times 0 square plus 3 times 0. Now we can simplify this function. S at 0 is equal to, so the first term will be a 0, the second term will be a 0 and the third term will also be 0. So that means the initial position of the particle is 0. Now since we have to find the time when the particle returns to its initial position, we'll sub in the position as 0 in the position equation and then solve for t. So this is the equation we have to solve. So the first step here is to factor this equation. So we can do common factoring here. So we can factor out a t. So we get 1 over 3 t squared minus 2t plus 3. So now we get two cases. So the first case is t equals 0. So t equals 0 represents the starting time when the particle starts moving. So t equals 0 cannot be the time at which the particle returns to its initial position. So this is an invalid answer. So the second case will be 1 over 3 t squared minus t plus t equals 0. Now we can simplify this equation. So this is a quadratic equation and we can get rid of the denominator 3 by multiplying each term on both sides by 3. So we'll multiply the first term by 3, the second term by 3, the third term by 3 and also the 0 by 3. So we get, so 3 times 1 over 3 will just be 1. So we get t squared minus 6t plus 9 equals 0. Now this is a simple trinomial, so we can factor it using sum and product rule. So we have to find two numbers whose sum is negative 6 and product is 9. So the two numbers are negative 3 and negative 3. So the factored form for this equation will be t minus 3 times t minus 3 equals 0. So now we have both factors the same. So we can rewrite this as t minus 3 squared equals 0. and we can get rid of the square by applying square root to both sides. So the square and the square root cancel each other out. So we get t minus 3 equals 0. And now we can solve for t by adding 3 to both sides. So the 3's on the left side will cancel each other out and we get t equals 3. So this should be the final answer for part C. So that means the object or the particle will return to its initial position at 3 seconds. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to understand what's given in the problem and what we need to find. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.